So my name is Mark Jack. I'm a faculty member of physics down in Tallahassee, Florida. I'm not at FSU, I'm at the other smaller school, Florida A&M University. I went there about 14 years ago to try to help build a PhD program in physics. I'm a theorist by training. Done everything from particle physics to computational neuroscience at UCLA. So you probably hear my funny accent. It's German. My mom is German. Grew up in Munich mostly. Did my PhD in Berlin, and in 2000 I came back to the States. My dad is from Detroit. And so it was great to come back and kind of explore the scientific landscape here. And then in 2003 I heeded a call to kind of go to Tallahassee to try to help build a PhD program in physics at a historical black college. There are only 3 in the country that have a PhD program in physics. Family is one of them. So I did that, reinvented myself a couple of times in different arenas, mostly doing nanoscience, high performance computing the last few years, and then about 3 years ago I got interested in data science due to a mutual friend of Frank and I's, he in Atlanta, Peter Molnar. Some of you guys might have met him. He runs sometimes a meetup over at GSU and is one of the faculty members over there at their analytics program. In any case, what have I been doing with Frank? Kind of grabbed me about a little bit more than a year ago to help him with organizing and co-teaching his R boot camps, which I think were, especially the second one, fairly successful. First one was kind of a trial over 8 weeks where we had 4 or 5 students. We cleaned up the lecture notes, the hands-on exercises, and added some stuff with a capstone project in the second round last fall for 10 weeks, where we went over everything through how to work and wrangle a data project all the way up to machine learning details and how do you optimize your performance of algorithms. And so that's my background in terms of data science, and now I'm transitioning into Python for the last 2-3 months. So a lot of this stuff is new to me too, so if you have any questions, please interrupt me immediately. And Frank and I will figure it out together to try to answer the question. So that's kind of where I'm coming from. I would say anything else, and Frank, as mentioned, is kind of going to start another boot camp in R, and a Python boot camp is planned for the fall. So you might see me in some of those sessions again as a co-instructor for anybody who's interested in signing up. So what do we have planned for the day? Again, we had no idea of what the general background is of folks in Python. I just heard that some folks are not kind of heavy-duty software developers, so I'll basically play it by ear. If you want me to kind of slow down or do something else, just interrupt me. So we've got so Frank created a whole bunch of material. Most of it is kind of introductory. A lot of these folders you don't see, but Frank is going to upload and create access to you for whichever folder we're going to be working in. So you have a whole bunch of material here. Analyze data, prepare data, because a lot of this material, so these are introductory materials on how do you upload a data set, how do you wrangle a data set, how do you do some fundamental visualization. Most of those are Python scripts. Because we're using IPython Jupyter Hub, IPython Notebook, I could show you how to run those. Let me quickly backtrack for a second. Anaconda. That's the tool I use, and when you install that, you'll also have on your laptop self-contained Jupyter Notebook environment, including in IDE. How does it look like? So I have a separate Anaconda session after you've installed it, and it comes with a whole bunch of nice little tools. Jupyter Notebook is one of them. Spider is a nice IDE that allows you to manipulate and work with Python scripts. You can switch back and forth. That's kind of the developer environment I like, and a lot of people use it that way. So Frank on his platform has Jupyter Notebook installed. The Spider IDE is not available there. But that's what I, for example, would use to illustrate some of these Python scripts that are in here. So there's an example, data loading in this folder, 01 analyze data, data loading, and you see most of these are Python scripts. So let's see what happens when I click on it. So you can at least have a look at it, but I can't run this directly in IPython Notebook. What I could do is copy this into individual cells, but I'm not going to go through all that drama. We have some Python notebooks set up that kind of have a lot of that content as well. Just for later, if any of you guys want to keep playing with this stuff, Frank will probably provide access to those Python scripts. So you can do the same thing these Python scripts do by copying and pasting some of these individual commands into a Jupyter Notebook environment, or you can install Jupyter Notebook with Spider or whatever IDE you like, the other IDEs out there, to run these Python scripts. So if you want to know more about that, ask me during the break or afterwards when we're done at 12. I'm happy to give you a couple of pointers. But, I mean, it's fairly straightforward. So Anaconda, where is it? Anaconda is the website where you can get that material. And there are other ways of kind of setting yourself up with Python compiler. Other folks love like PyCharm, and so there are other tools out there. But Anaconda is very, very popular because it's fairly straightforward and easy to get started. Kind of similar like RStudio in R, so you have that kind of nice self-contained environment. So let me get to the actual folder I want to use, Intro to Python Workshop. Frank has that set up.
You already have it in your folder.
Should be in your folders now. There's a quick IPython notebook Frank also created, Learning Python 3.ipynb, a Jupyter notebook where a lot of the things Frank initially mentioned of how to manipulate these cells is again summarized here. So you can use that as a reference, basic operators, doing fundamentals in Python and how to work with Jupyter Notebook, what the different types are, and so on and so forth. So that'll be available too if you want to.
Where do I find this data? I'm not seeing this. Which directory? I'm in the Jupyter.
Which user are you?
15.
15. You already have it in. Yeah, it's if you go to in Jupyter, you have intro.
Yeah. Sorry, I had
Yep.
to refresh.
Yep.
So everybody has that access?
Intro to Python.
Got it.
So I hope most of this works. I basically sat down with Frank yesterday to kind of try to fix a lot of these things. This was initially written, prepared for Python 2.7, and we switched to Python 3.6. So a lot of these older scripts we fixed on the fly. If there's an issue, we'll see, but Frank can quickly fix it. It has had mostly something to do with access rights to some of the data sets we're using. So we'll see what happens, but most of it should be fixed by now. So Intro to Python Workshop, so you have a whole bunch of example scripts in here. This is mostly kind of introductory stuff to functions, methods. I hope you can read that, or do you need me to increase the font size or something? Is that too small, maybe for the folks in the back? Is it okay?
Yeah.
If there's something you can't see, understand, just scream. Again, this is a meetup, I mean, this is for you guys. So interrupt me if any of this is too boring, I can jump to something else, or we can kind of quickly move ahead and then look at the machine learning stuff, statistical inference, and all those more interesting topics. So that's a little bit, we're trying to get some feedback on what the general kind of interest area, knowledge is of folks here in here. So here you've got essentially Jupyter Notebook on fundamentals in Python. So how do you deal with variables, strings, numbers, lists, and these are again mostly kind of examples for you to play around with and follow along. I'm getting familiar with the language, and so the key thing here was that's why these parentheses look a little funny. We have to quickly put parentheses around the arguments of the print statement. That's kind of, in most cases, what the difference between, for most of these scripts, the difference between the Python 2.7 or 3.6 is. If anything doesn't work, check that first, and that typically fixes most of the conversion issues. And if any of you know more about that, please chime in. Some of you guys probably are much more well-versed in this, and so if you, for example, you go into the cell and hit shift return. That should execute that, and so you see that's a quick little hello world program. So this is an example for strings. So you embed or you enclose the strings with double quotation marks, hello world, semicolon, and then you enclose that in single or double quotes. I mean, a lot of this stuff is already explained in the
Is
commentary.
that basic for everybody, is it, or?
So a lot of this stuff might be very fundamental, so.
We'll get
yeah.
into the scientific a little faster. If it is, yeah, if you think it's really low level.
Yeah, so I'm going to scan through this very quickly. So a simple print statement to do an addition you see here, fairly straightforward. You can do the operation within the print statement. Here, if you basically, as soon as you use decimal points, then this is going to be computed as a float. If you don't, it'll be computed as an integer. If you add an integer and a float, then of course you have the usual type conversion into floats. So nothing unusual here. What is this down here? Here you do some slicing of a list, and there'll be some more example on what lists are. So lists is kind of mutable selection of variables. They can be of different type. That's not the case for an array. NumPy arrays, that's an immutable collection of elements of the same type. In this case, splicing. So you have your square brackets that defines a list. If you use other parentheses, you have other types of objects, and I'll get to that in the next notebook. But this is one of the fundamental type of data structures you can have in Python. You of course don't deal with that. Well, you mostly don't deal with that, but you switch to NumPy arrays or pandas, but we'll get to that later. And so this is an example of how you can slice. Again, Python starts counting with index 0. So 0 to 2 means you're selecting the first two elements, the elements with index 0 and 1. So it stops at, so when it stops at 2, that means you're not including A of 2, but you're just taking A of 0 and A of 1. And so you're printing that. And so these are a couple of examples of print statements. Here you're slicing 0 to 1, that means you're just taking the element A of 0, or you explicitly highlight that one element and it just prints that one element. A of negative 1 means you're taking the last element in that list, which would be 3. And so if you when you execute this shift return, you see you get these as expected results, and this is kind of an example of how you can print such a string structure. And that's a very, very simple graphics solution, very simple example of how you kind of create such a simple graphics. And here you have a couple of exercises you can do if you like. Later, I'm not going to bore you with these things. Again, a quick summary of what type of fundamental operations you can do: addition, subtraction, division, multiplication, calculate the modulo, less than, greater than, less or less than, equal, greater than, equal, and so on and so forth, is equal to. So an identification you're doing here for Boolean statements, for example. We'll have some examples on that later. The not statement with an exclamation mark, and then doing subscripting and slicing through lists, and we'll do some more of that in a second. What else do we have down here? And then here is an example of how you can append to a list. So how can you add elements to a list using the append command? And you kind of see here the fundamental structure of Python. You have an object, and you call a method with the dot, and then specify the name of your function, your method behind that. So this method is a method that's attached to this particular object. So here you have an empty list. So you have kind of just your square brackets, nothing in it. And so now you can add elements to that empty list step by step. So it'll simply, I guess, concatenate to that list these individual elements, and you can reverse the order by the reverse statements. Pop means you knock off the last element. So a.pop, and printing that will tell you which element you're removing. and then print that's element 3 from the original list. The important thing is that the A dot reverse does not change the actual data structure itself. There's a technical way of formulating that, what that means in Python. So you're not, applying a method does not change the data structure itself.
The order is by the index.
Yeah.
The index is not sortable. It retains that.
So it's still, so when you execute anything with A, it basically still refers to the original definition of that data structure. And we'll get into doing copies and identifying two lists with each other. So, next one, variable surprises might be interesting. That's the next script of that list. That refers to that, so you want to do multiple assignments. You can execute that. So in this case, you have this variable, these three variables A, B, C that I identified, and so this is essentially the same variable. So any modification you're making to A will also affect B and C. So this is not a simple copy. If you want to do a copy, there's a method called .copy, and that'll make actually create a new variable. So any modification of the older variable won't affect that new variable. But if you just do an identification like that, essentially it's like a pointer in C++, where whatever modification you're making to your variable is also going to affect all the other variables that have been identified as well.
So that just gives us 3 different ways to identify that variable.
Exactly. Exactly. It's essentially the same variable, just has 3 different names. And if you want to create a new variable, you need to use the .copy statement. Here you can kind of identify each one of these with a separate value, though, so you can do that. Print statement here, then these don't have to be of the same type, just another example that you can identify these variables as different types. So you have a float, an integer, 2 strings here, and then a list of 3 elements, 1, 2, 3. And you can, simple little examples where you can kind of manipulate strings like integer, floats, and Python knows how to interpret that. So A plus B simply means you're basically concatenating these strings one after the other. So mu and ha as 2 strings, and you do A plus B, that means you get the string basically connected with each other. And sometimes I'm going to get an error statement like that, and I don't know what that is, that orange bar up here. So sometimes you might have to reload that page in order to get your current Python 3 kernel up and running. That's some issue I mentioned to Frank yesterday, and I don't know. That's something he's going to look into, what's going on there. But if you just reload your page, that should fix the issue, that should allow you to run stuff. And so you can do other things like multiply with 2, that just basically repeats this list of integers in this case. So you're repeating the list, you're not manipulating the individual elements themselves. You can do a reverse statement. So this is this in place commentary I was saying earlier. So in this case, the dot reverse statement doesn't return a result. So you're not manipulating the variable itself. You're basically just doing transformation to it in order to feed into another function or some other application later. So you're not directly manipulating the original variable 1, 2, 3, and thus when you hit the print statement, you don't get a result. You can do a sort, A dot sort, so, and oops, what else? 1, 2, 3. And again, if you identify this statement directly with the variable name, then again, then that doesn't yield any result. And yeah, these weird kind of error statements have something to do with access rights, which I'm not sure what's going on there, but I guess that's something Frank will have to fix in the long run. What else do we have? Advanced variables. I think, let me see. Yeah, this might be relevant. So you have other structures in Python as well. Again, I'm not an expert in some of these details. So you have other things like tuples and dictionaries. So a tuple is similar to lists, but these elements are immutable, so you can't change the individual elements. So you identify that by using round brackets. And otherwise it looks like a list. Same subscript notation, so if you want to have essentially an object of elements that you can't change, sometimes that might be relevant, you can use a tuple. You can't append to it, that's why I get an error statement, because this is an immutable object. What else can you do? Then you can create dictionaries. Dictionaries are essentially kind of a selection of key-value pairs. So you have a key and a value. It's kind of like a tuple you're used to in maybe mathematics, where you have two elements. Well, the first element is essentially the key, and the second element is the value, and you can call them accordingly with methods, commands like dot keys. That'll print out the key. In this case, you've defined a dictionary. So dictionaries you define with curly brackets, and you specify in here you have two strings essentially. The first string, my key, in inverted commas, is your key, and the second string, my value, is the value. And you can then call either the value of that particular key by simply stating the key. It's like an index, more or less, but an index that you can kind of define any which way you want to. It doesn't have to be an integer. So it's like an index of strings. So when is that useful? It's typically useful when, for example, you want to create a dictionary of names with email addresses, where the names are your keys and then the email addresses would be the values. So examples like that. So I guess this is relevant when you're trying to create web pages or text documents you want to later mine. So for that, these dictionaries, this object dictionary is useful. And you can print out the values with the dot values command. That's kind of, maybe as far as I understand, dictionaries, just as an example. So tuples and dictionaries as examples of other type of variables. Copy a reference. Again, an example of what happens when you're trying to make a modification to a list, so declaring a new list equal to a previous list doesn't create a new copy, but essentially it's just you creating a new variable name, more or less, for the same variable. So any modifications you make into list A will also affect list B, and that's an example for this here. If you want to create a copy of a list, one way of doing it, for example, is to fake a slice. Kind of a tricky, a nice little way of creating a copy, or you could use list A.copy should yield the same result. So I can try that quickly, see whether that does it. Let's say list D. List A.copy. I hope that does it. And print list D. So you can play around with this stuff. That's what it's intended for. Let me see what I can move ahead to some more interesting stuff. Yeah, so it worked, basically. And and so you see also list D wasn't modified, only list B, because list B is just a renaming of that same variable, while list C and list D are actual copies. So different ways of how you can create a copy. But that's something you have to be aware of when you write your code, that kind of the traditional way of what you're used to in C, C++, or Fortran, where you essentially create a new variable by just doing kind of an identification of an equal sign, that's not true in Python. So you have to actually do an explicit copy. And these are two examples of how you do it. Conditionals, that's probably more interesting. Let me actually, so if you want to shut down any of your running scripts, which is sometimes useful, you can just go into that little tab up there called running, shut it down. So we're here at conditionals. No surprises with conditionals, the usual if then else statements. So again, I guess the key thing is you do if and then the actual condition you want to meet and then colon. That's kind of the structure in Python. The other key thing here is, and that's something somebody also had to tell me first, because I couldn't understand when my code wasn't working, you need to do, when you do an indentation, you have to do it by exactly 4 empty spaces every time. So I think a tab will basically do that automatically for you, but to be on the safe side, you always have to indent by 4 spaces, and so Python doesn't use parentheses or brackets for these to organize these functions and methods, which we'll get to later, or these individual branches in an if-then-else statement, but you have to use indentation. You do indentation by 4 empty spaces. So this is an example of a couple of select if statements in here. So you have you're testing some Boolean statements. So if true, then print. Okay, then this will always print. If false, then this should not print. And so accordingly, there's a funny little statement put in here. If this gets printed, there's something horribly wrong, so it shouldn't get printed, and it doesn't when you execute it. If 1 is equivalent to saying if true. So true is always true and 1 are identical. So that's interpreted as a true statement. If 0, then that's interpreted as a false statement. Again, if this gets, so there's a little kind of string that would get printed if this actually got executed, but it shouldn't, and it doesn't. So you can kind of run that, and then you see that for the first if statement you get a printout as expected. For the second if statement you don't, you shouldn't, and so nothing happens, good. And then if 1 gets executed, because that's a true statement, if 0 does not get executed, because that's a false statement, and so on and so forth. So this is just playing with Boolean algebra, more or less. Then your usual if-else, so in Python, if, then the condition, colon, the actual execution you want to happen, the actual methods that you're going to run in here, and then else with a colon, and then 4 empty spaces again to indent. So that indentation is key, otherwise you're going to get an error statement, and it has to be exactly 4 spaces. And then you also can use if, else, if statements in Python that's formulated as ELIF. So if you come from other programming languages, this is very easy to adapt to. And yeah, again, interrupt me at any time if any of this here is too trivial or some things aren't clear. If I can't answer it, I'm sure Frank can. So. Loops, for loops might be interesting. How for loops are organized in Python. So kind of similar to other languages as you're used to, with a for I, and then you have some enumeration. So you're running some index I, in this case, following a list of 7 integers. So that's one brute force way of doing it. And then you can kind of do your print statement in this case, and you execute each one of these statements inside. And again, you end that initial command with a colon, and you have 4 spaces as indentation for 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 what should get executed in that for loop. In the simple for loop, and so you see it'll evaluate I times 2, I squared. You see you get accordingly these values, and you can basically do manipulations with strings accordingly, so very straightforward. And this just runs it over these 7 numbers. You can do get a similar result if you use the command range 7, but keep in mind so range 7 creates essentially a list of 7 integers successively, but in this case it starts with 0. So Python always starts counting at 0 if you don't specify anything else. You can modify that. So a lot of these things you learn by doing. You're looking up stuff, you copy and paste from other authors, and you realize, oh, okay, I got the index wrong, that's the reason why. But range, for example, allows you to specify your starting value. So if you want to achieve the same effect as explicitly defining that list of 7 integers, you just do range 1, 8, meaning you start at 1 and your cutoff is 8. So your last index I is going to be 7. So that that right-hand value does not get executed. But this then has the same effect as the earlier way of resolving the issue, and then you have other things you can do. You can also specify, do a little bit more with range. And there's another command for floats. This is just right now for integers. So you want to kind of create a successive list of integers. And that's kind of an elegant way of defining and running a for loop. And you can run a for loop also over not necessarily just a list of integers, but you can run over a list of strings as well. So that's one of, I think, the most, I don't know what you want to call it, powerful, one of the nicest features in Python. You have a lot of flexibility of how you can run a for loop over. For example, you have a column in a data set, and you want to run over the specific values that can show up in that column, and you can nicely, quickly, and easily define that for loop without necessarily having to do it with the integer indices. You can use the string values in that column to be kind of what you're iterating over. And so this is just an example where, again, for integers, you can specify where you start, index 2, last index would be 23, and the comma 2 means you're skipping over every other one. And so this will run from 2 to 22 in terms of integer values, and you have the same function you want to execute that print statement. If you want to know more specifics about that command range, you can look it up by using simply the help command. So that's kind of that, and Google essentially are your friends. That's how I operate as a physicist. I'm not a software developer, computer scientist. I want to be use this stuff to solve problems. So if I know how to do something in R, and I want to copy it into Python, don't quite know what the command is, I'll look it up using Stack Overflow and some of the other tools. So learning by doing, copy and pasting, and asking others the quickest way, kind of brute force, quick and dirty way of doing things. But it gets the job done, and that you basically want to get things done. And that's how you should kind of look at these boot camps as well. Don't expect to kind of having to know everything perfectly. Something doesn't work, ask. Typically, that's the quickest and easiest way of kind of getting things done. And then play around with it. Use the help function. And R Studio has done, of course, similar functionality that quickly allows you to figure out how things work, what a function does, what a certain method, how a certain method is structured. We might highlight that later when we do some of the things like linear regression and so on and so forth. So here, while statements exist, of course, as well, and so I hope everybody knows how a while statement works. The interesting thing here is this little, the way this is structured, this print statement, that might be more interesting than the actual while statement. So the while, as you expect, in this case, you're iterating over some integer and its value, so while I is less than 3, and you have your starting value I equals 0, the way you expect you would do it in C or C++. The modification is you have a colon here instead of curly brackets. and you have to do your indentation by 4 spaces, and everything that belongs to that wild space is indented by 4 spaces, 4 empty spaces. So this belongs to this wild statement until you basically get back to the initial column, and then that defines it for Python that this is a new command that does not belong to the while statement. Anyway, the most interesting thing is maybe this print statement where you can specify placeholders, and into those placeholders you can plug in different values. So the statement here, the counter is null, and in curly brackets 0, curly brackets 1, curly brackets 2 means that these 3 input values are going to be injected here for these 3 placeholders in that order, that as a Boolean statement, I guess, is true. So if you execute it, or when you execute it, that's what you get. I could modify this. Let's make this I times 2. I'm going to see something different. Is the counter is now 0, and I times 2 is less than 3. Let's see whether that works. That should. Zero is less than 3, yeah. 1 and 2, 2 is less than 3, yes. But 2 and 4, 4 is not less than 3, and you get a false statement as you would expect. And so that's a nice way of how you can kind of add, execute different values within your. So this is useful when you have essentially a string you want to output with some with a value execution of some integer or float or something, and so you can do that by including this format statement and creating these placeholders with these curly brackets. And I apologize for this constant stuff, but that's some issue with, I guess, me executing things as a user. I don't know. I guess Frank will figure it out after we might meet up what's happening there. So, break and continue, break statements, I don't have to go over that. I think everybody's seen break statements, and so that's how you do it. And break out of a while or a for loop or whatever. So, and there's a little exercise in the bottom for anybody who wants to play around with it later. Let's see, what else do we have? So those were loops. This was nothing. Reading from files and writing from files. Writing to files might be interesting. So let's see. And I hope, let's see, Frank, that's where I had an issue earlier in terms of when I executed something.
This is what you want to try it again?
Yeah. Let's see, sample. What was that? Sample data. It must be in there.
Yeah, looks, that's,
So I hope most of this stuff works, but some of it broke, so we'll get to that. There are all kinds of different ways of how you can read in data, and I think we're going to have some more examples later. Or a lot of the Python scripts that are in those other 2 folders I quickly highlighted in the beginning have much more examples of other ways of how you can read in a CSV file, a text file. So there are a plethora of different options you have in Python, like in R. Have a look at that if you like. You will have that material available to you, and you can copy and paste that into a Jupyter notebook and execute it that way, or use some IDE you're familiar with. If you need help with that, let me know, or let Frank know. So this is just one example of how you can read in a .txt, so a text file. You have your open command. You're creating, then you want to read that data. So you first created that variable name of, and then with the command .read, that allows you to read that text data. And then with .close, you'll close the opening of that file. So print string, and so you get this famous Latin text, I guess, that's very often used as a lorem underscore ipsum as an example of how you kind of start in the field of text mining. What else do we have? You can read lines with the .read lines command. What are we doing here? We're doing a for loop over the range of length of my lines. So you first evaluate the number of lines this text data has. So let's just execute it. Did we print that? No, we didn't. So let me add that. So let me add a little print statement here. Print, so we know how many lines that is. Print in parentheses my underscore lines. That could be interesting. My lines, those are the actual lines, and to kind of use length of my lines. So essentially, you're creating a vector with my lines, and then you evaluate the length of that vector with the command len. And then you can run a for loop over the length of that vector. That's why I'm adding that print statement, because I'm curious myself of how many lines do I actually have. And it looks like we have, what, 9 lines? So let's see. You print the index, you print the line, so you see this is, well, the vector might not be the, is it the vector? Vector array, either way, so so you have your index I for the row index, and then you're printing out the first 25 characters, I believe, and then add dots. So this text file is interpreted as kind of a vector or an array of characters, and you can print it out that way. So let's do that. Shift. Yep. So we've got 9 lines, and then line 0 will, in this, the way this for loop is created, prints out the first 25 characters in that line, and then adds 3 dots at the end. So that's one way of doing it. It's just one of many ways of how you can read in a data set, in this case a text file. This is repeated down here. You can then do all kinds of fancy little things like splitting the text and so on and so forth. What else does Frank do here from collections? Import counter. So this is an example where how you import a new package, a new library from collections. Collections is the library you're using here. So I guess that's some library, some package in the context of text mining. The actual methods you want to call, in this case, the method counter. If you don't want to read in the full package, but only certain aspects, certain methods, then you can import the corresponding commands like this, import counter. Otherwise, another way of doing it is when you call the method counter, is just do collections.counter. Then it will, but what you're doing there is you basically, for efficiency reasons, if you know exactly which methods you're going to use, it's best to do it this way, with importing the individual methods you need. However, if you're playing around with that package or library a lot, and you're going to be using a lot of methods, then you might as well just import the whole package. And then you can specify which method you use by doing collections.counter. Sometimes that's actually even necessary. Again, this is kind of a layman's idea of mine about Python. Sometimes it's necessary when you have colliding function names. So when you have function names from different packages that are identical, then that's the way you can kind of specify which function you want to use. Just define the package library name dot the method. So it's always the same philosophy in Python. The method is called, and you can daisy chain methods too. So you can basically add, or what do you call it, piping methods. You can add one method after the other by dot method, dot method, dot method. If you want to have a successive number of methods applied to some data set you're manipulating, and that makes it kind of very powerful and compact and elegant. R has similar features, but it's not quite as compact as Python in that respect. That's one thing I like about Python. You can daisy chain methods. That makes it very, very nice and handy for data science applications, and I think that's one of the reasons people like using it. So in this case, counter simply counts the number of words in the text file, and you're printing out here counted words, so you see there's another method involved here. Most common, I guess that's something, that's a method that comes with that package, and so you've created that new data set. In this case, what is this? This looks like it's a list due to the square brackets, and a list of pairs with a string and associated integers, so the integer is the number of words for each one of these, what is it? For each text up by white space, for each one of the lines, so you can execute that, and gives you that list of information. What else do we have? This was a statement that didn't execute earlier, now it does. There was some issue with access rights, sorry, in terms of that data set, so this is just a hello world program again. Or some text file that has this information included. And so here's an example where you can run a for loop over strings, which is nice. So over a list of strings, it doesn't have to be integers or floats. So Python has a lot of flexibility there. That again makes it very nice when you kind of want to slice through a data set. You can specify, for example, string values instead of having to redefine everything in terms of a vector with integer indices first. So again, the open statement of dot write, you're basically writing something. You're printing the index. On the index are these individual words, and then you can write that back, I guess, with of dot write. What else do we have down here? Did that work? No. What's missing? So I hope most of this stuff should work, but every now and then there was some issue. Sample data, blah, blah, blah.
See the parentheses.
The parenthesis is missing, yeah. So every now and then you'll probably realize something isn't working because I missed fixing those parentheses, switching from Python 2.7 to Python 3.6. So here, just a couple of examples of what you can do with this string data, with these text files, defining of backspace and otherwise. So again, I'm not an expert in text mining or anything of that sort, but yeah, a couple of examples of what you can do. What else do we have? Writing two files maybe quickly. Yep. Yep. Just execute all this so it's okay. Yep. Again, how do you write? As you would expect, use the dot write method. Close the file after you open it again, and you can print. In this case, I specified the full, the complete path to that file. You don't have to do that, as you see down here. The usual kind of way of how you would do it in a Linux, Unix environment. /sample is another way of just specifying that you're in that folder and you're basically trying to go into the folder sample _ data and access that file. Nothing new. Again, that range length sentence construct is created. So you calculate the length of this vector, which is 3, and then you run over these, run with the index I being an integer from 0, 1, 2, and then evaluate this again. Or write out the result, and you then close the file.
Mark?
Yes.
Excuse me, when I open that file, mine starts at 4 instead of at 1 like yours does.
Oh, it's just a matter of executing. It depends on which order you execute these statements. Because of rerunning some of this stuff, if you do that, then it'll automatically update with shift enter. That'll do it.
This
That'll
is
always
one of
tell
the
you which is
reports
the last
of-
cells,
of
last cell you
Python,
executed.
Jupyter for that.
But that's the beautiful thing also about Jupyter Notebook. You can go into a cell and re-execute it, so you don't have to run the whole script again. So it's like a playground in which you can do much more advanced things, like create an R Markdown file, as Frank mentioned, So it's a nice development environment where you can kind of bounce back and forth. The way you would want to have it when you're doing web development or you're working through a data project where essentially you kind of hit maybe some roadblock and realize I should have done things differently in the beginning, so you can modify quickly some method you just applied and re-execute that stuff. So having that kind of modular approach towards solving a problem is very, very nice, I like. There's a little bit the advantage of writing one lengthy Python script and executing that. Typically I do that at the very end when I'm kind of comfortable with my analysis and I have kind of some modular module I've created, then I can copy everything into a Python script and have it ready when I kind of later want to do kind of some, I don't know, some production level type of stuff where I want to run kind of, when I essentially have established the analysis I want to do on my data set. And so these are the examples of how you can write out your data. Nothing substantially new. It's 10 to 15. Let's see. String formatting is probably not that interesting. Working with dates is not. So you have different kind of libraries you can work with dates. I guess probably the most important thing is what's the library. Date time is the library, and then you can import different kind of methods like the date method, which has another series of different methods integrated in that, and so you can do nice manipulations of temporal data, specify year, month, day, and the formats in which this is printed out. And Frank also nicely gave you kind of your listing of options, how you can manipulate or change the format of how this data is printed out. Very basic stuff here, but you kind of know where the corresponding library is that you need. Intro to functions, methods, and modules. Let me quickly go over that, and then I'm going to recommend that we switch to kind of maybe some more of the data science interesting stuff, kind of linear regression and things, and let Frank set that up. Intro to functions. How is the function defined? You use the def command, the function name, and then the argument list with colon. So very straightforward. Again, the commands in that function that are supposed to be executed. All you need that, again, you need that indentation by 4 empty spaces. So my first function in this case is just supposed to do a simple addition of 2 variables that are being input. But here it's not specified what type these variables have to be. So Python is kind of very bare bones, so you don't have to specify the type here. That of course creates a lot of flexibility as well, so if you put in an integer or float or strings, then it'll try to execute that. So you see that, actually you see that directly here when you execute it. You can input 2 strings and it'll interpret to use the addition statement as concatenating these 2 words, so you can execute that. And this I1 and I2 are now these 2 instances of this this class, or this object in this case, this realization of this class in terms of an object. Now that you've put in these 2 variables, you've created an object of that class, a realization or instantiation of this class, and you can give it a variable name, I1 and I2, and then call it down here in your print statement. And what else? And then of course you can do more than just a constructor. You can add other methods within that class. In this case, there's another method, tree class. So what does that do? So you have another method called name self. So you take that initialized object in here and do something with it. What do you do? Self.a1, self.a2, you return that in a very specific format. So when we execute that, brought to you by Dan Dye and Jason Keane. So these 2 placeholders are now replaced by so these individual objects, I1 and I2, have now methods associated with them, and those methods are defined in that initial class. And so the method name that I'm calling now specifies the, and in this case, the first and the last name of each one of these objects. So it specifies both the first and the last, these two objects, when I input that. So it's fairly straightforward of how you can define a class and then use the class to define individual objects. And all the methods you want to apply with respect to those objects, you pack into that class. And so that's this object-oriented philosophy that comes kind of straight out of C++, I guess, that you see here implemented in Python. And then you can kind of do an exercise and kind of create your own class of address attributes and so on and so forth, print the address. Polymorphism and inheritance, let's see. So again, you have here two classes defined, triangle and rectangle, have the same constructors, the init method, and then separate method, a method called area, but that's evaluated differently. For the triangle, of course, it's taking those two input values and multiplying them and divide by 2, so that's the height and the width. If you interpret it as height and width and then divide by 2, but for the rectangle, you just multiply height and width. And so when you execute that, realizations of that class in terms of the object R or T, which in this case you specify the two with 3 and 4, the height and the width of that. I mean, this is an example of geometric objects. You can execute it that way, and you get 12 and 6 as expected. As expected, yeah, because you call the rectangle first and the triangle. Okay. Inheritance means you can call classes within. Let's see. The class triangle inherits from shape, so you can define a new class from a previous class. So you kind of have an Überclass, or sorry, that's my German background. That's why I have to laugh when somebody created a company called Uber. But so you have a superclass type of thing which you call in order to define subclasses, and all the methods, so the constructors directly inherited. So that constructor method from shape is directly inherited for these new classes, triangle and rectangle, as you see here, and then you can add additional methods. So that's probably one of the other really nice, powerful features in Python, this object-oriented aspect of being able to define classes and methods. And modules, I think, what's the difference to modules? Not that much. It's just, again, define a function down here. Class down here with the inheritance. Shows up UI. Oh, I think the idea is that you can use that to define a Python script or something that kind of creates that class with those methods by simply encapsulating it. Python hello.py, it has nothing else. Has that definition of that class or method in there. And so if you have an object or a class you want to redefine, reuse, so this is a simple example of how you kind of start creating your own modules, more or less, by defining classes and packaging them in a Python script. Because these packages are nothing else, when you do import a package, is nothing else but a Python script that contains all these definitions of functions, methods, classes, and that's what you call them. And so this is an example of how you can start creating your own packages. So fairly straightforward. Shapes import, and you see that down here. You can import and hope this executes now. Nope. So there's some issue with, and I don't know whether you want to have a look at that later, Frank, in terms of.
Yeah. That's a good segue into.
Yeah, no, I think it's a good break
You're
for,
done?
yeah.
Yeah.
Maybe we should
Okay.
take a 2 to 3 minute
Let's
bathroom
take
break.
a